Hi everyone, I am Dheeraj and my other teammates are Jayanta Nanduri and Sachin. Today we are presenting the project for initial pitch for CS6140, which is the narrative visuals AI's take on the image generation. To start with the goal of the project, so it is to develop a state-of-the-art image generation system driven by nothing more than line of a text. Our vision is to weave this technology into the fabric of social media, creating an application at the forefront of the NLP and computer vision. The platform will allow users to create personalized images through a synergy of textual descriptions and visual inputs. We aim to bridge the gap between the written world and the visual art, giving the power to the people to bring their imagination to life. We want to foster a community where sharing these AI-assisted creations is as simple as sharing a thought. In closing, this project is more than just a tool. It's a canvas for the future, inviting every one of us to paint with ideas. Moving on to why the project is interesting, the image generation through AI represents the forefront of the technological innovation. It combines various fields, including deep learning, computer vision, and NLP, to create images that can be indistinguishable from those captured in the real world. Investigating the challenges and the limitations in AI-assisted image generation is essential for understanding the current gaps and the opportunities for improvement, as it sheds light on areas where further research is needed. From now, my teammate Jayanta Nanduri will continue.
The approaches we plan to explore in this project. Initially, we have conducted a literature review and we found out about generative adversarial networks, which are really popular back in 2014. And the problem with generative adversarial networks is mainly they require a large amount of training data, and even though we have collected a large amount of training data, the training such a network is still unstable, and they also suffer from something known as mode collapse. Mode collapse is something where the model keeps generating examples of a certain type, so it is not generic. And to further explain, we are going to use stable diffusion. Stable diffusion is a model where we give a textual input and a random Gaussian noise. And the way we combine these two is the crux of the model. So now, if you see, the text prompt given to us will be converted into a text embedding, and the image will be gradually produced with the help of these text embeddings. Now, if you see how we are going to generate these text embeddings is the text embedding and the image will be in the same latent space. And Sachin will further explain about the U-Net architecture.
So a quick overview of what U-Net is. U-Net is an architecture that's like a U shape. It has two main parts, a part that looks at the big picture, the entire context, and a part that focuses on small details. It's called localization. So this is crucial for making realistic images. U-Net helps the model understand and recreate intricate patterns in pictures, even when given specific instructions are like as small as text descriptions. So it's like a bridge that connects the big picture and the fine details to make image looks natural and detailed. In order to tackle the limitations in current generative models, the rationale behind why we are taking this up is we need to find new ways to improve the quality and variety of the generated data. Recent research has shown promise in addressing these issues, particularly with the use of latent diffusion models. By adopting these innovative techniques, we can benefit from the latest advancements and potentially overcome the challenges that we have identified. Furthermore, our approach involves exploring a wide range of generative models and methods. This not only helps us to address the shortcomings seen in previous approaches, but also expands the scope of our research and knowledge. By doing this, we can thoroughly investigate different possibilities and come up with more effective and adaptable solutions for image generation. So the timeline for conducting this project on the weekly basis. So we plan to do the project scoping and the comprehensive literature review, the continuation of it in the week 1, followed by data acquisition, compilation, and in-depth model exploration for the week 2. Development of the model and subsequent refinement and all will take place in the week 3, and we'll be presenting our findings on week 4. This is how we plan to divide the work in the team. Thank you so much for this opportunity. Yeah.